This is Mrs. Heathcote with Engage New York or Eureka Math, Grade 4, end of Module 3 review test. Number 1, what is the greatest multiple of 6 that is less than 57? So in this situation, the word multiple means skip counting. So let's write skip counting above the word multiple to help us remember. Then we can just start skip counting by sixes. Because that's our number here, right? 6. So we go 6, 12, 18, 24, 30. And then I'm just using my fingers to count, or I'm counting up in my head, or I'm using my times tables to keep going. 36, 42, 48, 54, 60. Uh-oh. 60 is too big, right? Because the directions say, what is the greatest multiple of 6 that is less than 57? And 60 is bigger than 57, so that would make 54 my correct answer. Make sure that you actually circle 54 or write that it equals 54 so that your teacher can give you the points. On number 2, I apologize, I don't know why, but this line printed badly, so let me put it up there. And then number 2 says, identify whether each number is prime or composite, then list all of the factors of each number. I think this question's a little backwards because we actually need to list the factors first so that we can decide if we're going to write prime or composite. So let's start with 2. What are all the different ways that we can multiply to get to 2? Well, there's only the one way. We can multiply 1 times 2. So this number is prime because it only has 2 factors. It has exactly 2 factors. Now let's think of all the ways to multiply to get 10. We can go 1 times 10, and we can do 2 times 5. So that makes this number composite because it has more than 2 factors. On the next one, we have 18. So we have to think of all the ways to multiply to get 18. I always like to start with the 1 and the 18 so that I don't forget it at the end. And then we have 2 times 9, and we have 3 times 6. That makes this number composite for sure. You do have to be careful to make sure you don't miss any, because if you don't list all of the factors, like if you forgot the 3 and the 9, then you won't get full points. So you have to check them. Check 1, you'll always have 1. Check 2, is it even? See if 3 goes in, 4, 5, 6. And now I'm back to 6, to that halfway number, so I know I'm okay. Then we have 17, so we write 1 and 17. And then we check, but 2 does not go, 3 does not go, 4 does not go, 5 certainly doesn't go because that would be 15 or 20. 6 doesn't go, that would be, because I know 6 goes into 18. And so this number is prime because it only has 2 factors, exactly 2 factors. Be really careful, boys and girls. 9 is a tricky number. Lots of people want to say it's prime because it's odd, but it actually has 3 factors, 1 and 3 and 9, so 9 is composite. All right, let's move on. Number 3 says use any place value strategy to divide. So with this one, you can do it long division if you want to, but I really like to just simplify it into unit form. So I'm going to say 54 hundredths divided by 6. So that lets me just think about 54 divided by 6. If you go back to your skip counting, you would remember that that would be 9 times. So it would be 9 hundredths. And then I can just write it correctly or in standard form. 9 hundredths equals 900. Let's look at part B. Part B says apples come in 26 apples per crate. If Mr. Dixon, Mrs. Dinsdale, and Miss Harmon's classes share 4 crates equally, how many apples does each class have? With our read, draw, write strategy, we should be drawing our crates, and I'm going to put 26 apples in each one. And then I need to divide all those apples up between the 1, 2, 3 classes, right? So one way to do it is to add them all up and then divide by 3. So let's start there. So I'm going to go 26 times 4. Instead of adding them all, I'll just multiply. 4 times 6 is 24. I need to do my plus 2 there. 4 times 2 is 8. Plus 2 is 104. So now I have 104 apples, and I need to divide by 3. Before I do long division, I like to write down the steps, which is to divide, multiply, subtract, bring down, repeat, divide, multiply, subtract, bring down, repeat, right? Or remainder if you end up finishing the problem. So let's go ahead and see what this looks like. If I have 1 divided by 3, that would be 0. It won't, I can't divide the 1. I can't share it. So then I have to look at the 2 digits. So we'll look at the 10. 10 divided by 3 equals 3. Why? Because 3 times 3 is 9. And then when you subtract, you get 1. After I subtract, I bring down. So I bring down the 4. And I do 14 divided by 3. 14 divided by 3 is 4, because 4 times 3 will give me 12. And that's pretty close to 14. When I subtract, I get 2. So the 2 is the remainder, right? Word problem. Word answer. Before I give my word answer, I do like to reread the problem. And it says, how many apples does each class get? So then I can start my sentence with each class gets 34 apples with 2 left over, or 2 remaining, or 2 extra, however you want to think about it. All right, if you want to pause here to look at this, I'm going to go back and redo some stuff. So another way to have thought about this problem is to realize that if I have 3 classes, I could start by just giving each class a box. So that means each teacher gets 26, right? For Mr. Dixon, Miss Dinsdale, and Miss Harmon. And then I only have to do the math for 1 box. And so I would go 26 divided by 3. Well, 26 divided by 3 doesn't work, but I know 24 divided by 3 is 8. 8 times 3 is 24. Subtract, you get 2. Remainder of 2. Then you add the 8 to that 26, and you get 34. Don't forget your remainder of 2. Still a word problem. You would still write the answer. All right, good job. Let's go on to the next one. Number 4 says to practice solving by drawing place value discs and then solving numerically. All right, so you can do either one first. I'm going to go ahead and do place value first. I like to write my place value chart in red to set it apart from my discs so I don't make it too messy. Hopefully, that's always the goal, right? And then I'm going to put my discs in here. We'll go 1, 2, 3, 4, 5. Oh, and then I need 7 there. So 3, 4, 5, 6, 7. And then 1, 2, 3, 4 there. I apologize about my discs. They're hard to draw on the iPad. And then I'll do my red squiggly line to separate what I started with what I'm making in my sections. How many sections do I need to be able to divide? That's right, I need 6. So there's 1, 2, 3, 4, 5, 6 sections. I like to enclose mine so there's no confusion. All right, and let's start. All right, when I look at these 3 cannot divide into 6 spaces, so I'm going to have to decompose them. So I cross it out and I draw 10 in my tens column. And then I cross out the other one and I draw 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I cross out the third one and I draw 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 2 of those didn't draw very well. Now I have to go through and cross them out and put them into my chart for my 6s. So if I cross out those 5 and one more, that'll be 6. Then I can cross out 1, 2, 3, 4, 5, 6 more. And I do it again, 1, 2, 3, 4, 5, 6. It's really important that you keep these nice and neat. 4, 5, 6, because you have to know which ones you crossed out and which ones you didn't. 1, 2, 3, 1, 2, 3. See how I almost didn't cross it out? That would have been a problem. And then I have my last 5, 6. Ooh, and let's not forget him. I have an extra. All right. And that extra I'm going to have to decompose into my 1s. Now I have 14 in my 1s column, and I need to divide them up into my sections. So I'll go 5 and 6 crossed out. 2, 3, 4, 5, 6. And then these 4, 5, 6 crossed out. And then it shows that I'll have a remainder of 2 that I can't forget. So then when I count these, I end up with 62 remainder of 2. But it says I also have to solve numerically. So I'm going to go ahead and solve it using long division. We have 37 divided by 6 because 3 doesn't work. So 37, which is the same number of discs that I had here in my tens place, were 37. So 37 divided by 6 equals 6, because 6 times 6 is 36. That's as close as I can get to 37. I subtract, I get 1, which is the 1 that I had left over up here that I had to decompose into the 1s column. I bring down the 4. Here's the 14 that I ended up with in this part of my place value chart. 14 divided by 6 equals 2. Look, that's how many I ended up with. 2 times 6 equals 12. Subtract, you get 2. That's a remainder of 2, which is the same remainder I ended up with up here. This time we get to use any place value strategy to multiply or divide. So we have to make sure we're following the directions. On the first one, we're going to assume it's division. So we need to take 5,492 divided by 9. I'll go ahead and do it long division. When I do long division, I like to write the steps. So let's start. Divide, multiply, subtract, bring down, repeat, divide, multiply, subtract, bring down, repeat, right? And it can be repeat or remainder. So if I go 5 divided by 9, that means I have 5 things that I want to share with 9 friends. You can't do it evenly. So we're going to have to put a 0 up there and move to the 54, right? 54 divided by 9. I can also think, like if you don't like 54 divided by 9, you can think 9 times what equals 54. And then go through your 9 skip counting or your 9s times tables, and you'll come up with 6. 6 times 9 is exactly 54. We subtract and get 0. Now we bring down the 9, and then we repeat 9 divided by 9. That equals 1, right? Because if I have 9 things and I share with 9 friends, everybody gets 1 thing. 1 times 9 is 9. Subtract, I get 0. I bring down the 2. I divide 2 divided by 9. It doesn't go at all, so that equals 0. You have to put the 0 above the 2. If you don't, it'll be the difference between an answer of 61 or 610, and 61 would obviously be wrong. So then we go 0 times 9 is 0, and you subtract and you get 2. Since there's nothing left to bring down, the 2 becomes your remainder. All right. Let's start with our multiplication. So now we have 34 times 18. So I really like partial product, like the 4 partial product, so I kind of do it the long way. I'll end up with 4 equal signs. One of my equal signs will be for the ones column times both columns in the other number. So I get 8 times and then 8 times. And then the other 2 are going to be for multiplying the tens column times the bigger number, okay? And so I end up getting 10 times and 10 times. Be careful, a really common mistake is people will say that this looks like a 1. That does not look like a 1. It's totally a 10. So you have to be really careful, okay? So now we have 8 times, and now we've got to do it times the 34. So it's going to be 8 times 4 and 8 times 30. Again, be careful. This does not look like a 3. It is definitely a 30, okay? Then for the 10, we do the same thing. We multiply it times the 4, and we multiply 10 times 30. Here we go. 8 times 4 is 32. 8 times 30 freaks me out a little. So I can just go 8 times 3 is 24, but I have to have it as 24 tens. So I put a 0 in the ones place, and that gives me 240. Really important that you're careful about that 10, right? Now I have 10 times 4. I can handle that. That's 40. But now that it has 10 times 30, I freak out that I'll make a mistake. So what I do is I take the zeros and I put them in the place value chart as my ones place and my tens place. Now I can multiply 3 times 1. Then we add 2 plus zeros is 2. 4 plus 4 is 8, 9, 10, 11. For that 3, I have to carry the 1, and that gives me 4 plus 2 is 6. 612 is my answer. Another way you can check it that a lot of kids feel more comfortable with is you can also go 34 times 10 and 34 times 8 and just do it as 2 separate problems. 34 times 10, lots of you might know, is 340 just by looking at it. And then 8 times 4 is still 32. 8 times 3 is still 24. 25, 26, 27. And then you have to add these 2 numbers up. And so 340 plus 272 is still 612. Check it out. Doesn't matter how you do it. So cool. Math is awesome. All right. So that was the rest of number 4. Let's move to number 5. Solve using a model or equation. Show your work and write your answer in a statement. All right. Mrs. Farnham is getting new carpet in her classroom. Her classroom is 18 meters long and 12 meters wide. How many square meters of carpet does she need? Use estimation to assess the reasonableness of your answer. So I like to just start with a picture. So I'm going to draw this rectangle, and I'm going to say that it is 12 meters on this side and 18 meters on this side. So 18 meters long, right? My length equals 18 and my width equals 12. How many square meters of carpet does she need? Use estimation to assess the reasonableness. Oh, that's right. Use reasonableness. I'm going to have to double check, do my whole problem over again using estimated numbers. All right, but starting with my real numbers, area equals length times width. So I'm going to have to multiply 18 times 12. So last time I did it with the 4 partial products, right? But this time I'll do it standard algorithm for anybody who likes to do it that way. So standard algorithm, I go 2 times 8, right? My ones columns. 2 times 8 is 16, and I do the plus 1. And then 2 times 1 is 2, plus 1 is 3. I do like to cross out my plus 1 so I don't try to use it again. All right. Then we have 10 times 8. 10 times 8 is 80. And then we have 10 times 10, but I can think about it just as 1 times 1 because it'll already be in the hundreds column. And then we add these together, and you get 8, 9, 10, 11, 6, 11, so that would be 2. All right. Yeah, and that's all she's asking. How many square meters? I always reread my problem. How many square meters of carpet does she need? So that I can do word problem, word answer, right? She will need 216 square meters of carpeting. But that does not assess my reasonableness. So now I actually need to do the problem again with estimated numbers. So if I take the 12 and I say that 12 is about 10, and if I use 18 and say 18 is about 20, now I can multiply 20 times 10 to get my answer. Well, 20 times 10 would be 200. 200 is about the same as 216, so my answer is reasonable. And I don't have room, but I would write, yes, maybe I can squeeze it in. I would write, yes, my answer of 216 is reasonable because it is close to my estimate of 200. Sorry for skipping around there. If you want to pause to really think about that, this would be a great time to do that. All right, the next part says, the classroom also needs new chairs and tables. 2 times as many chairs as tables were ordered. If there were 56 chairs ordered, how many more chairs than tables were ordered? This is for sure one of those that you might want to read more than once. So, let's see here. I know we have 56 chairs, and I have twice as many chairs as tables. So I'm going to have less tables. So let's divide that by 2. The classroom needs new chairs and tables. Got that. I can ignore that. I don't need to read it again. 2 times as many chairs as tables were ordered. If we did 56 chairs, how many more chairs than tables? Well, let's find out how many tables were ordered, and then we can subtract to find out. All right, so I have 56 divided by 2. When I do my division, I like to have my steps. So we divide, multiply, subtract, bring down, repeat. Divide, multiply, subtract, bring down, repeat. Although my division sign looks like an adding sign, so I'll fix that. Okay, here we go. 5 divided by 2 would be 2. 2 times 2 is 4. Subtract, I get 1. Bring down the 6. 2 goes into 16 8 times. 8 times 2 is 16. Subtract, I get 0. So my answer is 28 without a remainder. So that's how many tables I have. But the question is how many more chairs than tables. So now I have to take my 56 chairs and subtract my 28 tables. 6 minus 8 doesn't work, so I'm going to borrow or decompose the 5, giving me a 16. 16 minus 8 is 8. 4 minus 2 is 28. Word problem. Word answer. There are 28 more chairs than tables. So here we have pencils were ordered in boxes containing 9 pencils each. The grade level has 104 students. If the teachers want to start the year with 7 pencils per student, how many packages do they need to buy before the school year starts? So if the grade level has 104 students and each child is going to have 7 pencils, we want to start by multiplying 104 times 7. And so if you use the partial product way, we would do 7 times 4, and then 7 times 0, and then 7 times 100. But I think this is actually a good problem to use the standard algorithm. So let's go ahead and do that today. So we've got 7 times 4 is 28. I like to write the plus 2 so my brain remembers to add it. 7 times 0 is 0. Plus 2 is 2. And then 7 times 1 is 7. So the grade level, they will have to buy 728 pencils altogether. But the pencils come in boxes of 9, right? So now I have to take that 728 and divide it by 9 to see how many boxes I need to buy, right? So 7 divided by 9 doesn't work. That would be a 0, because if I have 7 things and I want to split it amongst 9 people, nobody can have a whole thing. So then I look at the 72 instead. 72 divided by 9 is 8, because 8 times 9 equals 72. You get to subtract in that 0, bring down the 8. 9 does not go into 8, so that would be another 0. 0 times 9 is 0. Subtract, I get 8. So 8 is my remainder. So if we buy 80 boxes, we will end up with 720 pencils. Is that enough pencils? It is not, because I need 728. So how many boxes will I have to order? If 80 won't work, how many boxes will I need to order? Yeah, I'll have to order 81 so I can get that take care of that extra kid, right? Right, and it says, how many packages do they need to buy before the school year starts? So, word problem, word answer. They will need to buy 81 packs of pencils. Remember, because if they only buy 80, there's going to be a kid who doesn't get any, right? Okay, let's go to the next problem. Oh, and it's backwards, sorry. Here it is. So Mr. Ezor's bicycle is locked with an old-fashioned combination lock. Here's a picture of what a combination lock looks like. In order to open this lock, you need to turn the dial to the correct numbers. The first number, 32. The first number is 32. The other numbers can be multiplied together to get a product of 56. What are all of the possibilities for the other two numbers? Write your answer as multiplication equations and then write all of the possible combinations for the safe. Okay, so these combination locks are really funky and they take a little practice to learn, but it's really important that you learn them because you'll need them for high school with your lockers for PE. So it tells us that the first number is 32. The other two numbers multiplied together will equal 56. So I need to be thinking of all of the factors of 56. Well, we could multiply 1 times 56. We could multiply 2 times something. Let me do the long division on that one. 5 divided by 2 is 2. 2 times 2 is 4. Subtract, I get 1. Bring down the 6. 6 divided by 2 is 8. So it would be 2 times 28. 3 does not go in because 5 plus 6 is 11. And 3 doesn't go into 11. 4, I think 4 goes in. Let's try. 56 divided by 4. 5 divided by 4 is 1. 1 times 4 is 4. Subtract, you get 1. Bring down the 6. 4 goes into 16 4 times. 4 times 16 is 16. Subtract, I get 0. Subtract, I get 0. So yeah, 4 times 14. 5 does not go in. 6 does not go in because 9 times 6 is 54. 7, oh yeah, 7 does go in because you have 7 times 8. All right, so let's read it again. In order to open the lock, you need to turn the dial to the correct numbers. The first number is 32. The other two numbers can be multiplied together to get a product of 56. What are all the possibilities? So it might be 32 and then 1 and then 56. Or they can change the order. It could be 32, 56, and then 1. What are all the possibilities of the other two numbers? Write your answers as multiplication equations and then write them all. So they want this as a multiplication equation. So I'm going to write equals 56 on all of these. Be really careful that you do that. That's a way lots of kids make mistakes, is because they don't do this in multiplication form. All right, but we've done that now, so we can go back over here. Another one would be 32 and then 2 and then 28. And then you can change the order again, 28 and 2. The reason I'm not changing the order of the 32 is because it says it's the first number. So now I've done that one, right? So I can do 4 and 14 next. You do not want to cross those out on your test. Your teacher will go crazy. So now we've got 32 as the first number, but then I can do 4 and then a 14. But it might be 32 and then 14 and then 4. So you have to be careful to write it both ways. So now I've done 4. Ooh, maybe check marks would have been a better idea. My last one is 7 times 8. So I can do 32 and then 7 and then 8. Or it could be 32 and then 8 and then 7. Write your answers in multiplication equations. Did that. And then write all of the possible combinations for the safe. And those are them. Try to keep it organized. Remember that you're going to have 3 numbers in each one, and that then the ones that you found in your equation will then be reversed. All right, and I think that's the end of your test. Let's see. Yep, that's the end. Best of luck to you.